Let's examine the randomize deep structures option in the ordinal analysis crossed orderings procedure. Now recall that when we randomize all observations, what we're doing there to compute our chance value is randomly shuffling the data that we see in the data spreadsheet. And here we're randomly shuffling the data for the first ordering, in this case the time or the reaction time. So we just randomly shuffle that column of numbers, and we do that over and over again to generate the randomized PCCs. Now when you randomize by deep structures, things are going to be quite a bit different. There we're going to randomly set up the data, randomly create really new data based on the deep structures. I'll explain that in greater detail. Let's cancel out of here for a moment, and let's create the deep structure for the reaction time. So I'll select Edit and create deep structure. Select the, not gender, but reaction time there. Select OK. And here we see the deep structure representation of the data. Now the way I defined these data originally was I set every whole number as a unit of observation. So the lowest score was a 6, and then 7, 8, 9, you can see here, going all the way up to 27. Now the first individual scored a 1, the second individual scored a 12, see where the 1 is there. The third individual scored an 8, the fourth scored a 10, and so forth. The 27 was here for case number 7. So this is the deep structure. Now when you randomize by deep structures, what you're going to do is determine row by row. What the program's going to do is determine row by row where that 1 is located. So here the 1 is at 6. If I randomly determine that, it could be a 15, it could be a 23, it could be a 6 again as well, but it's going to be any one of these places. And each of these units has an equal probability, if we want to use that word, of being the location for the 1. And then for the second case, we're going to do the same thing. We're going to figure out, or randomly determine rather, where that 1 is going to be located. So you see, in this way, we're going to really generate new data. So it could be the case that when I randomly generate the deep structures, I don't see a single 6 for the 15 individuals. I might not see an 8, for example, or I might see multiple 8s. Here I've only got 1 or 2 individuals who have 8s rather. Maybe in a randomized version of it, there are 4 or 5 8s. That would be unusual perhaps, but it could happen. So you're creating new data essentially. You're not just randomly shuffling the data you have, you're randomly generating data based on the deep structures, which you have defined as the researcher. So it really is quite a bit different. So let's go back to the data set here, and then let's run the analysis again. Crossed orderings, and now we're going to randomize based on the deep structures. Again, we can save the randomization results if we wish, and select OK. Iterates through. There's the PCC, 87.5. Obviously, that's not going to change any. We can just hit enter here a few times to scroll this up. And for the deep structures, the minimum PCC was 5.36, maximum 92.86. 5 out of the 1,000 then were equal to or greater than 87.5. And so that gives us a chance value within rounding of 0.01. So again, it appears that the data should be interpreted in terms of cause and effect rather than just the product of physical chance in terms of the deep structures now. And again, we can go back and look at the randomized data. Here I'll just select it as the last one in the data set here, the list of data sets. And let's look at the distributions here. I'll go ahead and magnify this, or maximize it rather. We can drag some things over here so we can see all the column labels. Select distribution, and there are our PCCs. So there is the minimum 5.36, there's the maximum 92.86, and again we can see the values that were 85.7 or above. Or was it 87.5 perhaps? I think that's what it was. So there were 5 values here above that, but the vast majority of the values were much lower. Again, we get a normal looking distribution here, but that's not expected. It's not necessary, I should say, when you're analyzing your data. Your particular data set, you may get a skewed distribution, a uniform looking distribution of PCCs. That doesn't matter. We don't make any assumptions about the distribution of the data or the population. So we don't know what the PCCs will look like here from the randomization test. They can be distributed in any manner possible. So again, then we can randomize by the deep structures to choose between interpreting our data in terms of cause and effect or in terms of physical chance, in terms of generating the data within the confines of the deep structures that we have defined.